Hello, welcome to Chemistry First Quarter Test Review, Chapter 2. So in this video, you're going to need your calculator. You're going to need the question sheet. And that's about it. I went ahead and started out by putting the formulas from this chapter up here at the top. So all of these you'll need to have memorized for the test. Before I get started, if this video helps you out, please consider buying me a coffee. There's a link in the description box, or you can scan a QR code here. It's just a $3 donation to help compensate me for the time. All right. So question number 1 from chapter 2 is convert 57 degrees Fahrenheit to Celsius. Okay, so Celsius, we're going to use this second formula, is 5/9 times 57 minus 32. So the way you want to put that in your calculator is, let's put the 5 divided by 9 in parentheses. And then times another parentheses, 57 minus 32. And then close those parentheses. And you'll get 13.88, so we'll round that to 13.9 degrees C. Okay, number 2, we're converting negative 14 degrees Celsius to Fahrenheit. Okay, so in this case, our Fahrenheit temperature, we're going to use the first formula up there, 9/5 times degrees C, so times negative 14 plus 32. So in this one, the 32 is outside the parentheses. Okay, so I'm going to put 9 divided by 5 in parentheses times, and you don't really need to put the negative 14 in parentheses. If you want, you can go ahead and hit enter now, and you'll have a number. And then just hit plus 32, and then hit enter, and that is 6.8 degrees Fahrenheit. So that's a cold day. And then number 3, we're going to convert 149 Kelvin to Fahrenheit. So I'm going to do this in 2 steps. First, we're going to convert that to Celsius, and then we'll convert it to Fahrenheit. So if we use this equation, we'd have 149 is equal to degrees Celsius plus 273.15. I'm going to get rid of the K here. So to solve for C, let's subtract 273.15 from both sides. All right, and we would have here 149 minus 273.15. That's negative 124.15 is equal to our Celsius temperature. Now we're going to use that and convert it to Fahrenheit. So we know that Fahrenheit is going to be 9/5 times this negative 124.15 plus 32. Okay, so I'm going to put that 9 divided by 5 in the calculator times negative 124.15. I usually hit enter there, get an answer, and then just add 32 to that answer. And you have negative 191.47. All right, so that should pretty much catch all the temperature conversion type problems that you might get. Now let's go ahead and get into the heat and the calorimeter problem. So number 4 says how much energy is required to heat a 22.4 kilogram glass window, and it has a specific heat of 0.8372, from 25 to 41 degrees C. All right, so how much energy? So we're solving for Q here. Energy is heat. So Q is equal to MC delta T. Now the mass, we're going to need to convert that to grams. So we have 22.4 kilograms. I'm going to put that over 1. Going to convert that to grams. Cancel out kilograms. The 1 goes by the bigger one. There's 1,000 grams in a kilogram. So you'd have 22,400 grams. So now Q is equal to the mass, 22,400 grams, times the specific heat, that's 0.8372 joules over grams times degrees Celsius. And then delta T is the final temperature minus the initial temperature. The final temperature is 41 degrees Celsius. The initial temperature is 25 degrees Celsius. So we're heating it up. We're going to get a positive heat, positive energy. So that makes sense. So in our calculator, the way I would do it is 22,400 times 0.8372 times, and then we're going to left parenthesis 41 minus 25, and then right parenthesis. All right, that's 300,052, and you could put 0.48 if you want. We'll go ahead and put that. We're not rounding to the appropriate number of significant digits. If it asks you that, then we would have to go through that. We'll just leave it there. All right. Number 5. So there we have, what is the final temperature of a 55-gram piece of iron? And it gives the specific heat. That starts with a temperature of 22 degrees C and releases 600 joules. So if it releases 600 joules, that means if we have Q is equal to MC delta T, that means Q is negative 600 joules. It releases or goes down by 600 joules. The mass is 55 grams. The specific heat of iron is 0.4521. And then I'm just going to solve for delta T, and then we'll get the temperature by using this equation. But first let's solve for delta T. So delta T, we're going to bring these two underneath Q. So we have negative 600J divided by 55 grams times 0.4521 joules over grams times degrees C. All right, let's put that in our calculator. Got negative 600 on top, divided by, and then I'm going to do left parenthesis, 55 times 0.4521. Now, I don't use two sets of parentheses in the calculator. I don't need that. I just did it for illustrative purposes here. All right, so times, and then right parentheses. And so that's negative 24.13 degrees Celsius. Okay, that's not the answer. That's the change in temperature. This piece of iron lost 24.13 degrees C of temperature, so it cooled down by that much. So now we can use delta T is equal to T final minus T initial. We're asked for what is the final temperature. So I have negative 24.13 degrees C, that's delta T, is equal to T final minus, And from the problem it says it starts with a temperature of 22 degrees C. So we're going to add 22 to each side. And I would have negative 2.13 degrees C is equal to the final temperature. Okay, started off at 22 degrees Celsius. Then it got cooled down by 24.13 degrees Celsius. It lost that much heat, 600 joules, lost that much. And we end up at negative 2.13 degrees C. All right, 2 more to go. So got the 2 calorimeter problems left. Those are the longer ones. The first one, number 6, all right, says a 38-gram bolt is heated to a temperature of 180 degrees C, dropped into a calorimeter containing 175 grams of water at 23 degrees C. The final temperature of the water is 27.1 degrees C. What's the specific heat of the bolt? And we get to ignore the heat absorbed by the calorimeter. Okay, we have our calorimetry equation. Minus Q of the object is equal to the Q of the water plus the Q of the calorimeter, and we get to ignore the calorimeter. All right, we don't have enough information to get the Q of the object because we don't know the specific heat. So I'm going to put a question mark there, but we can get the Q of the water. Have everything we need to know. That's MC delta T. The mass of the water is 175 grams. The specific heat of water is 4.184. You'll be given that on your test, but you've probably memorized it by now. And then the delta T of the water is going to be the final temperature, 27.1, minus the initial temperature, 23 degrees C. All right, so that is, I'm going to go ahead and write down, that's 4.1 degrees C. So it raised by 4.1 degrees C. So in your calculator, we've got 175 times 4.184 times 4.1. So that's 3,002 joules. Now, that's not the answer, but you are half done with the problem. Okay, so we know that minus Q of the object is equal to 3,002 joules. That means the Q of the object is equal to negative 3,002 joules. And we set that equal to MC delta T for the object. So I have minus 3,002 joules is equal to the mass of the object, which is 38 grams, so it's a 38 gram bolt, times the specific heat, that's what we don't know. And then delta T is T final minus T initial. Well, T final for everything is the same, 27.1 degrees Celsius. The water, the calorimeter, the bolt, all ended up there. But it started out really hot. And this is where, if someone's going to make a mistake with these problems, it's usually the delta T for the object. Okay, that's a negative number because you lost heat when you put that bolt in the water and it cooled down. So that's going to be 27.1 minus 180, which is negative 152.9. Okay, so solving for C, we're going to bring those two numbers underneath the negative 3,002. So C is equal to negative 3,002 joules divided by 38 grams times negative 152.9 degrees C. And I know I did the algebra right because my unit's going to be joules over grams times degrees Celsius. So if you'll look at the units, that'll help keep you from doing the algebra backwards. All right, I've got a negative on top and a negative on bottom. That's going to cancel out, so I'm not even going to put the negative in the calculator. So I've got 3002 divided by, left parenthesis, 38 times 152.9. And that is 0.52, which is reasonable for a metal bolt. So metal is generally less than 1 on the specific heat. So there you go. Nice calorimeter problem. Okay, let's do one more and then we will have finished our Chapter 2 video. I'll do Chapter 3 and 4 all in one video because that's going to be a little bit shorter problems, and these calorimeter problems are a little on the long side. Okay, number 7. We have minus Q of the object is equal to Q of the water plus Q of the calorimeter, and this time I don't get to ignore the calorimeter. So 50-gram piece of copper at 100 degrees C dropped into a calorimeter. That information's given. Heating the water from 25 to 26.5, what's the mass of the water? Okay, this time we can't get the mass of the water, so that's where I'm going to put my question mark. Or excuse me, we can't get the Q of the water because we don't know the mass, but we can get the Q of the object and the Q of the calorimeter. So the Q of the object is MC delta T. Now we'll get minus Q of the object later just by making it negative, but the Q of the object is the mass of the copper, which is 50 grams, times the specific heat of copper, which is 0.3851, and then the change in temperature of the water. So everything ended up at 26.5 degrees Celsius. That's the final temperature for everything. But the water, the object, the copper, started out at 100. Okay, so that's going to be what, negative 73.5. So I'll write that in, negative 73.5 degrees C. So I went ahead and did that in my head. You don't have to. You can do it in your calculator. So what I've got is 50 times 0.3851 times negative 73.5. And that is negative 1415.24. And that's the Q of the object. Let's get the Q of the calorimeter. That's MC delta T. So the calorimeter is 7.5 grams. Specific heat of 2. It's not a very good calorimeter. Should be a lot bigger than 2 if it's any good. And then it went from 25 degrees Celsius to 26.5 degrees Celsius. So the calorimeter, just like the water, raised up 1.5 degrees. Okay, so that's going to be 7.5 times 2 times 1.5 should be 22.5. Yep, 22.5 joules. So now we can do minus Q of the object is equal to the Q of the water plus the Q of the calorimeter. That's going to be minus 1415.24 is equal to the Q of the water plus 22.5. So this is, and those are joules. This is why you get to ignore the calorimeter a lot of times, because it just doesn't make that big a difference in the number. So two negatives make a positive. So we have positive 1415.24. It's equal to Q of the water plus the Q of the calorimeter, 22.5. We're going to subtract 22.5 from both sides. All right, so 1415.24 minus 22.5. That's 1392.74 is equal to the Q of the water. Okay, so we're almost done. So now we can plug in the Q of the water is equal to MC delta T. Okay, so the Q of the water is 1392.74 is equal to the mass of the water. We don't know that. The specific heat is 4.184. And then delta T is the same as the calorimeter. That's 1.5. So I'm going to bring these two underneath. So the mass of the water is 1392.74 divided by 4.184 times 1.5. All right, 1392.74 divided by left parenthesis 4.184 times 1.5. All right, don't put two sets of parentheses like I wrote it out here. How you write it out and put it in the calculator is two different things. I have had students have trouble with that sometimes. So we got 221.9 grams. That seems like a reasonable number. Okay, so that does it for this lecture. Once again, I'd appreciate it if this video helped you, if you would consider buying me a coffee. Links in the description box. You can scan that QR code. And I'm also going to put a link for our vinyl of the day. Today's vinyl is the band Boston from 1978. This album is called Don't Look Back. All right, there's the bottom of it. Pretty cool guitar spaceship there. All right, so give that one a listen while you're studying if that's something you can do or something you like to do. And I will talk to you on the next video.